Before I begin, I need to apologize about the audio on this video and my last video. I'm getting ready for hybrid learning at school, so I'm doing these recordings at school, and at home I have a big old mic that I can talk into, and my audio quality I think is pretty good. I noticed listening to the last video that the quality wasn't what I really like. Hopefully when my son puts this together in the video, he can adjust that. No guarantees. So I'll try to speak up, and let's do the best we can and get through 5.9. And by the way, this is the last section of Module 5. 5.9, can you get to the point? And when I was looking over this material, I was noticing we have a lot of the same problems. We've done many of these. So think of this as just an opportunity to really review solving systems of equations, become an expert at this. And you know, in the big picture, these problems might look a little more complicated than they really are, but we just need to break them down into tiny steps and be really careful with our arithmetic and algebra, and you guys will do fine. So, in shopping for cats and dogs, Carlos found a way to find the cost of individual items when given the purchase price of two different combinations of those items. He would like to make his strategy more efficient by writing it out using symbols and algebra. And we really did that in 5.8, so this is some extra practice. Help him formalize his strategy by doing the following. For each scenario in shopping for cats and dogs, write a system of equations to represent the two purchases. And to keep things real simple, depending on the problem, x will always be the first variable in the problem and y will be the second variable. Or in terms of cats and dogs, x will always represent anything to do with dogs and y will always represent everything to do with the cats. So, number 1. One week, Carlos bought 3 bags of Tabitha tidbits. So instead of calling that a 3T, let's just call that a 3X. And 4 bags of Figaro flakes. Let's call that 4Y. So 3X plus 4Y. For $43 equals $43. All right. The next week he bought 3 bags of Tabitha tidbits. So we have 3X again. And 6 bags of Figaro flakes plus 6Y. And how much did that cost? For $54 equals 54. Based on this information, figure out the price of 1 bag of each type of cat food. Explain your reasoning. And let's find the price for 1 bag of each type of dog food as well at the same time, you guys. So, if you look at these two linear equations in standard form, you see the 3x's and the 3x's. If we subtracted those two equations, our x's would cancel and we'd have one equation in terms of y. So those 3 x's, let's simply use elimination and subtract. Alright, so I'm going to bring down this equals right here and say 4y minus 6y's, that would be negative 2y's. And then 43 minus 54, that would be negative 11. And now, to undo multiplication by negative 2, let's divide both sides by negative 2. Bring down that equals, and the factors of negative 2 on the left cancel, so we have y equals, and a negative over a negative is positive. 2 goes into 11 5.5 times. So y is 5.5 or $5.50. Now, let's take that y and substitute it into one of the original equations. I'll use the top equation here. So I'm going to say 3x plus 4 times 5.5 equals 43. So what's 4 times 5.5? That would be 22. So 3x plus 22 equals 43. And now to undo adding 22, we will subtract 22. Bring down the equals. And 3x equals 43 minus 22, which is 21. And now we're going to divide both sides by 3. And let's see if we're ready to skip a step. And if not, please do it. But I like to look at this and go, 3 times what number is 21? Most of you can tell me that would be 7. So that implies x equals 7. And if you need to show the division, please do. So that implies a box of Tabitha tidbits would cost $7. Now, if I plug that 7 into, oh no, hey, I already did that. The Y is 5.5. That means a box of Figaro flakes costs $5.50, and we have answered the first question. Hopefully getting a little more efficient. Okay, number 2. 1 week Carlos bought 2 bags of Brutus Bites, so 2x, and 3 bags of Lucky Licks plus 3y for $42.50 equals $42.50. The next week he bought 5 bags of Brutus Bites, 5x, plus 6 bags of Lucky Licks plus 6y equals $94.25. Now, this one we couldn't add or subtract right away, because if we did, neither our x's nor our y's would cancel. So we need to think we better manipulate. And I'm looking at the y's here. Do you agree that 3 would go into 6 2 times? So could we take this top equation in standard form and multiply every term by 2? Elimination, we're manipulating. There's my 2 right there. Now let's rewrite it. 2 times 2x, 4x. 2 times 3y's would be plus 6y's equals, and 2 times $42.50 would be $85. All right, now, see the 6y and the 6y? We can subtract these equations to cancel our y's. Equals 5x minus 4x is x, 6y minus 6y is gone, and $94.25 minus $85 would be $9.25. All right. Now, let's substitute that x into one of the original equations. It doesn't matter which one. I'm going to use this one right here within the parentheses, ignoring that factor of 2 on the outside. That looks simplest to me, so I'm going to go 2 times $9.25 plus 3y is $42.50. Now, the stuff over here won't change, but let's simplify 2 times $9.25. And that would be what, $18.50? All right, now we need to solve for the y. So let's subtract the $18.50 from both sides. And we're left with 3y on the left and $18.50 from $42.50. Well, what would that be? Well, I'm a little tired, so I'm going to punch it out. I don't want to make a mistake arithmetically, so I'm going to go 42.5 minus 18.5, and I'm getting $24 even. So if 3 times y is $24, wouldn't y be $7? Implies y is, oh, excuse me, yeah, 3 goes into 24 8 times. $8. Careful, Gibbons. All right, so Brutus Bites, well, that was my x, which is $9.25. And Lucky Licks, well, that was my y, which is not $7, but $8. There you go, number 2. Number 3, Carlos purchased 6 dog leashes, can I call that 6 X's, plus 6 cat brushes, plus 6y, for $45, equals 45. I like that. For Clarita to use while pampering the pets. Later in the summer, he purchased 3 additional dog leashes, that would be a 3x, and 2 cat brushes, plus 2y, for $19, is 19. Now this system, I can't add or subtract right now, but I could easily manipulate the lower equation to either get 6 x's or 6 y's to cancel. So, what do you think I did here? I bet you I multiplied it by 2 to cancel my x's. Let's see though. Elimination. Multiply by, yeah, now I could have also multiplied by 3 and my y's would cancel. But let's rewrite. So 2 times 3x is 6x. 2 times 2y would be plus 4y. And 2 times the 19, that's an equals 38. All right, now let's ignore that middle equation for a moment and subtract. So if I do that, 6x minus 6x is gone. 6y minus positive 4y would be 2y. And 45 minus 38 would be 7. So if 2 times y is 7, isn't y 3.5 or $3.50? Divide both sides by 2. Cancel your 2's. You have your factor of y left. And 7 divided by 2 is 3.5. Now let's take this y and plug it into one of our original equations. I'll bet I used the middle equation before I multiplied by 2. Yep, so I'm going to go 3 times x plus 2 times y, which is 3.5, equals 19. So 3x plus 2 times 3.5 would be 7, or 2 times $3.50 would be $7. Now, let's get rid of that plus 7 by subtracting 7. And we have equals, and 3x plus 7 minus 7 is 3x. 19 minus 7 would be a 12. So 3 times what number is 12? I think you can do that right in your head. If not, divide by 3. But doesn't x then equal 3 times what number is 12? I don't want to make an arithmetic mistake again. That's going to be a 4. So, I think we have some answers here. X would be my number, our dog leashes, and they cost $4. And Y would be my cat brushes, which looks like a $3.50. And there you go, number 3. Number 4. One week Carlos bought 2 packages of dog bones. How about a 2x? I'm getting cute here. 2x right there. And 4 packages of cat treats plus 4y, and he spent $18.50. All right? Because the finicky cats didn't like the cat treats, the next week Carlos returned 3 unopened packages of cat treats. So if he's returning those cat treats and returning 3 unopened packages, wouldn't that be a minus 3y? Yep. And he also bought 2 more packages of dog bones. Let's add a 2x to that. After being refunded for the cat treats, Carlos only had to pay $1 for his purchase. So this 2x minus 3y will equal $1. All right, there's our 2 equations there. And look, the 2x's would cancel if we simply subtracted them. Nice. Okay? Equals, so 2x minus 2x is gone. 4y minus negative 3y. Well, remember, minus a negative is positive, so that would be 4y plus 3y, 7y. And $18.50 minus $1 would be $17.50. And now let's just divide both sides by 7. Equals, the 7's cancel, leaving the factor of y. And how many times does 7 go into $17.50? 17.5 divided by 7. Oh, $2.50. Nice. Okay. So, the cat, Y was measuring cat treats, right? So the cat treats cost $2.50. Now let's figure out how much those dog bones cost. So let's take this y and let's plug it into our bottom equation. Remember, this minus is not part of that equation. It's 2x minus 3y equals $1. So 2x minus 3 times y, which is $2.50, or 2.5 if you prefer, equals $1. So let's clean that up. So negative 3 times 2 is negative 6. And negative 3 times 50 cents would be another $1.50 off. So what's that? Is that negative 7.50? Minus 7.50. And again, don't be shy about a calculator. We can't afford arithmetic mistakes. All right, I made one earlier. All right, so now let's add 850 to both sides, or 750 to both sides. Here I go again. So I'm left with 2x equals $1 plus $7.50, which is $8.50. And now we can divide both sides by 2. equals, the factors of 2 cancel, leaving the factor of x, and $8.50 divided by 2 would be $4.25. So those packages of dog bones cost $4.25. Now, notice how I wrote this solution as an ordered pair. Right? When we typically solve systems of equations, our solution is a point in the plane. It's an ordered pair. And to really reinforce that, I'd like to plot this point in the plane. Here's the first quadrant of the coordinate plane, and where would 4.25, 2.50 go? Well, 4.25, well, that's 4.5, so it'd be about right there. And then let's go to 2.5. There's 1, there's 2. Right there. And there's that point. Now, if we graph those two lines, wouldn't they have to intersect at that point if we had done everything correctly? So, maybe we should find the intercepts of each of these. And instead of doing the typical table, I'll do that on the next slide. I'm just going to do my ordered pairs. At the y-intercept, x is 0. So 2 times 0 is gone, and I'm left with 4 times what number is $18.50. So I'm just going to go 18.5 divided by 4. 18.5 divided by 4. And I'm getting 4.625. All right. I probably rounded that. Well, okay, let's just go 4.625 because that's just an intercept. Okay, good. Wow, these are going to be a little uglier, but that's okay. All right. Now, at the x-intercept, my y is 0. So 4 times 0 is gone, and I have 2 times x is 1850. So what's half of 1850? That'd be 925. 9.25. There we go. Now, I don't know if I plotted those yet or I found my other intercepts. I'm probably going to find my other intercepts. Let's find out, though. Okay, so if the x is 0, my y-intercept would be, well, 2 times 0 is gone, and I have negative 3 times y is $1. Oh, man. So 1 divided by negative 3, that's going to be negative 0.3 repeating. Let's see if I did that next. No, it looks like I'm plotting right now up here. So I have my y-intercept of 0, 4.625. There it is. And my x-intercept of 9.25 and 0. There's 9.5, 9.25 right there. Now, check this out. If this point is correct, wouldn't the segment between my two intercepts have to go right through it? It looks good, but let's get a ruler out and check that. Look at that. Oh, I'm excited. All right, now let's go find this y-intercept. And remember, we let x equal 0, and we're left with negative 3y is 1, which means y is 1 divided by negative 3. And that's where we got that negative 0.3 repeating. Negative 0.3 repeating. You could have written that negative 1/3 too. Okay? And now the x-intercept, if y is 0, well, the negative 3 times 0 is gone, and I have 2 times x is $1. That means that x-intercept would have to be 50 cents. Oh, and I already plotted my y-intercept. And look, it's not in quadrant 1, so I just estimated. I went y, well, if this is positive 1/2, then negative 1/2 would be about right there. So there's my negative 0.3 repeating. All right, and now the 0.5 for an x-intercept would be right there. Now this is not perfect, but watch what happens. I get my ruler and I go through those two intercepts. Looks like I might miss a little bit. Let's see. Oh, look at that. It is perfect. So again, by graphing those two lines, we confirmed our solution of $4.25 for packages of dog bones and $2.50 for packages of cat treats. Isn't that cool? Bones, $4.25. Cat treats, $2.50. Oh, I like that problem. Okay, wow, and they just get bigger. Carlos has noticed that because each of his purchases have been somewhat similar, it has been easy to figure out the cost of each item. However, his last set of receipts has him puzzled. Remember this problem? 1 week he tried out cheaper brands of cat and dog food. On Monday he purchased 3 small bags of cat food, and I think we're going to call that a 3Y. And 5 small bags of dog food, how about 5X, for $22.75, equals $22.75. Because he went through the small bags quite quickly, he had to return to the store on Thursday to buy 2 more bags of cat food. That's my next equation, plus 2Y. Alright? And 3 more small bags of dog food. Let's put a 3X there. And how much did that cost? $14.25 equals $14.25. Now, again, wow, I can't add or subtract right now. And because 2 does not go into 3 and 3 does not go into 5, I can't just manipulate one of the equations. So I'm going to have to manipulate both equations. How about this? Could I take the top equation and multiply by 2 and the bottom equation and multiply by 3 to cancel my y's? Because again, if I do that, well, 2 times 3 is 6 and 3 times 2 is 6. That's going to work. There you go. So let's rewrite the entire system. So 2 times 5x would be 10x. 2 times 3y would be 6y. And 2 times $22.75, what would that be? $45.50. Okay? And then let's multiply by 3. 3 times 3x's would be 9x's. 3 times 2y's would be 6y's. And 3 times $14.25. Can we do this without a calculator? 3 times 10 is 30. 3 times 4 is 12, so we're at 42. And 3 times 25 cents is 75 cents, so that's $42.75. And again, use a calculator if you're not comfortable with the arithmetic. Now, do you see the 6y over the 6y? Let's subtract those 2 equations, and 10x minus 9x, x, and $45.50 minus $42.75. Well, that would be what? $2.75, I believe. And there it is. So those packages of dog food cost $2.75. I'm going to go to my ordered pair again, and we're going to graph to check everything out. Cool practice. All right, let's substitute that x is 2.75 into one of my original equations. I'm betting I probably use this one, 3x right there. Yep. So I'm going to go 3 times x, which is $2.75, plus 2 times y would equal $14.25. So what's 3 times 2? 6. And 3 times 75 cents would be $2.25. So that's $8.25. Now let's subtract that $8.25 from both sides. Equals, and on the left they cancel, leaving the 2y is, and $14.25 minus $8.25, wouldn't that be $6? So if 2 times y is $6, isn't y $3? Divide by 2. Cancel the 2's. I have that factor of y equals 6 divided by 2, which, look at that, 3. Now let's do the same thing. Let's plot this ordered pair in the first quadrant of the plane, and then graph both of our original lines to see if that's where they intersect. And what we're doing here is we're getting practice on solving by elimination and solving by graphing at the same time. I hope you're realizing that. So $2.75 for my x, that's going to be right in there. $3 for my y, 1, 2, 3, right there. Awesome. All right. Well, let's plot 5x plus 3y equals $22.75. All right, and do you want to graph by using intercepts? Of course we do. Those are in standard form. And I'm going to do this with the tables again because I don't know. I just think this is cleaner. So if my x is 0, 5 times 0 is gone, and I have 3 times what number is $22.75. So I'm just going to go ahead and do this division on my calculator. 22.75 divided by 3, and I'm getting, oh man, ugly, 7.583 repeating. How did I write that? Yep, 7.58, and note the bar over the 3 to tell the world that that 3 repeats over and over and over forever. Whew. All right, now if y is 0, I have 5 times what number is $22.75. So let's go 22.75 divided by the 5, and I've got $4.55. That's a little cleaner. All right, now down here, the x is 0 in the second equation, so 3 times 0 is gone, and 2 times y is 14.25. Well, that means y, well, let's go 14.25. 14.25 divided by the 2, and I'm going to have 3 decimal places here. 7.125. Okay, and now if the y is 0, 2 times 0 is gone, and I have 3 times what number is 14.25. So let's go 14.25 divided by the 3, and I've got $4.75. Now, when I plot these intercepts and draw my lines, those lines should intersect at this point if we've done everything right. Oh, let's do our best with 7.583 repeating. 1, 2, 3, 4, 5, 6, 7, 7.5, so 7.583 repeating would be about right there. Not bad. How about 4.55 for the x? So there's 4.5, so a little beyond that hash mark. About right there. Ooh, I'm a little right on it. I hope that works. Let's see if I drew my boundary line. Yeah, I did, and I think we have a winner. All right. Now let's go down to this y-intercept, 7.125. 7.5, so I'm going to say 7.125, about right there. Yeah, the cat's happy. And then 4.75, well, 4.5, so 4.75 would be about right there. Oh, those are kind of close, but watch. Dun, 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 dun. Get the ruler out and draw. I think we have a winner again. Nice job. So that graph confirms that we've solved this system graphically, and the solution is this ordered pair, $2.75 and $3. And when we used elimination over here, we had the same solutions. So how much do those dog food costing, those small bags of dog food? $2.75. And how much are what was that? Just small bags of cat food? That was $3. And there we go. Another problem solved. We're getting good at this. Okay. Carlos, oh, here's another one. Carlos purchased 6 dog leashes and 6 cat brushes for $45. So wouldn't that be a 6x plus a 6y equals 45? 6x plus 6y equals 45. For Clarita to use while pampering the pets. Later in the summer, he purchased 3 additional dog leashes, that would be a 3x, and 2 cat brushes, plus 2y, for $19. There you go. Now, I can't add or subtract right now, but I could multiply this bottom equation by 2 to get rid of the x's, or by 3 to get rid of the y's, and it doesn't matter which way. I probably multiplied by 2. Yes, I did. Hey, multiplying by 2 is easier than multiplying by 3 in my book. All right, so let's do that. 2 times 3x would be 6x. Oh, here, I rewrote the top equation, so I lined these up right here. So here's the 6x plus 6y equals 45, and then 2 times the 3x, a 6x, 2 times the 2y, a 4y, and the 2 times the $19 would be $38. And now we can subtract those 2 equations to cancel our x's and solve for y. So 6y minus 4y, that's going to give me 2y's, and $45 minus $38, $7. So 2 times y is $7, so y is $3.50. Okay, look, I skipped the division, and if you're not comfortable with that, don't do it. Alright, so there's my y coordinate of my ordered pair. Now, let's substitute that into one of the original equations. I'm betting I use this y. Notice how I look at the equations and what's the simplest? Yeah. So let's go. 3x plus 2 times 3.5, or $3.50, equals 19. So let's clean up that 2 times $3.50, which would be $7. Now you've got to subtract the 7. Oh man, I'm not showing you my work there. Okay. Well, as we go farther, most of you are probably going to do this. So you do know I'm subtracting 7 from both sides. So I go in my head now, I go 3x plus 7 minus 7 is 3x, and 19 minus 7 is 12. Okay? As long as everybody can clearly see you obviously subtracted 7 from both sides, that's fine. And 3 times what number is 12? That'd be $4. I didn't show the division either, and there's the $4. So starting to skip some steps. Don't do that until you're comfortable with that. All right, well, we're going to plot this ordered pair in the first quadrant of the plane, and then I'll bet you we're going to graph our 2 original equations one more time and make sure they intersect at that ordered pair. So 4, 3.5. 1, 2, 3, 4. 1, 2, 3, 3.5. Right there. Boom. All right. Now, let's do intercepts again. Oh, no. Man, I love to do intercepts when we have equations in standard form, but they are asking, do we want to graph by converting to y equals mx plus b? So we're just practicing algebra, so why not? It'll work. All right. I do think it's more efficient to graph equations in standard form using intercepts. But let's have some fun here. So here's this first one. Let's solve for the y. So you guys want to subtract the 6x from both sides. Yeah, I know, we're solving for that y. Oh, and do you believe it? I'm really thinking you guys are doing great here because I didn't show it. But look at what I'm going to do here. If I subtract 6x from both sides, on the left, okay, I have 6x minus 6x is gone, and I have the 6y is negative 6x plus 45. Now, I'm probably not going to show you the division by 6, but let's divide every term by 6. So 6y divided by 6 would be y. Negative 6x divided by 6 would be negative x. And 45 divided by 6, well, how many times does 6 go into 45? I don't think it goes in evenly, does it? Man, I'm tired. 45 divided by 6? No, it's 7.5. So plus $7.50. Now, if I graph this line using slope-intercept, it needs to go through this point if we've done everything correctly. And you see the y-intercept is 7.5. So there's 4, 5, 6, right there. Okay? And the slope is negative 6. So let's drop 6. So, oh, this is going to be a little tough here, but okay, there's 1, 2, 3, 4, 5, and 6. So I'm right there at 1.5. And then I'm running 1. So where was I at? I was at the 1.5, right? And I've got to run 1. Okay, hang on. Oh, heck, I'm looking at the wrong one. My slope is negative 1, you guys. Okay, that's better. So let's just drop 1 and run 1. There's the point right there. And now I draw a line that goes through those 2 points, and I'm hoping it goes through our ordered pair. And there it is. We got sloppy for a second, but it worked out. Okay, that's good practice. Let's convert standard to slope-intercept and do it this way. It's also a great job practicing graphing lines in slope-intercept form. All right, so this one, well, we got to solve for that y right there. All right, oh yeah, I'm happy to. So I go 3x plus 2y equals 19, and it looks like we're skipping showing some steps. So do you agree though we have to subtract the 3x from both sides? And if I subtract the 3x from the left, I'm left with the 2y equals, and then I have to subtract that 3x from the right, so negative 3x plus 19. And now let's divide every term here by 2. So 2y divided by 2 would be y equals negative 3 over 2 times x, plus 19 divided by 2 would be what? 9.5 plus $9.50. So now let's plot the y-intercept of 9.5 right there. And now let's use the right slope this time, negative 3 over 2. So I'm dropping 3. 1, 2, 3, and I'm running how far? I am running 2. I lost my arrow. There it is. 1, 2, and there's that point right there. So again, we dropped 3 and we ran 2, and now watch what happens when I draw the line through my y-intercept and the point I got after doing my slope. And there it is. It goes through our ordered pair. We know we have to be correct. So let's finish this up. Dog leashes must have cost $4 each, and cat brushes were $3.50 each. Man, this is fun. All right. Wow. I was hoping there was more, but that was it. So you guys now, this is what? 5.9. You guys please make sure you do the ready, set, go for 5.9, and you get a hold of me if you have any questions. Everybody have a wonderful day.